And I'm here tonight to talk to you about landslides. I'm going to tell you a little bit about how they're studied, how they're defined, some incidents that have happened, and talk about what we do about those things and show you some pictures of them as well. I also have a few short video clips that sort of give you the feel for what's gone on here and other places. And I think as we go along, I will make my presentation, and then if you have questions, I'm happy to entertain those questions from you. So as you can see, the name of my talk is When the Mountains Come to You. We'll all talk about let's go to the mountains. But if we wait around here long enough, the mountains come to us. And they ultimately crash down, get washed away, and go to the ocean and deposit on the ocean floor, and ultimately moved up to the trench in the Aleutian Islands, crunched down, popped up as volcanoes, and start eroding again. And that's a short story of what goes on and is going on here in California. So I'll start with an area that I'm particularly interested in. I have a student working out here now. This is the Black Hawk landslide. And you're looking at it from a view out in the Mojave Desert, looking back towards Big Bear. And this is a aerial shot from an airplane by Kerry C. You know probably more from fault studies. He's now in Indonesia, but this shows you the outline of a landslide in here. And you can see the little ridges that have formed the sides of it, the splay out here in the toe region of it, and the definition of it as it sits on the desert floor out here, and came out of these mountains in a single catastrophic event greater than around 17,000 years ago. You cannot hear? Need it louder? Can you turn me up? Is that better? Yeah. All right. I know how you feel. I know I look normal, but I'm not. I actually have these new hearing aids in that are called Lyrics that stay in your ears for 2 or 3 months, and I'm sort of a guinea pig on these. But anyway, so I may not quite understand your question, but I'll come up and we'll get clear on that as time goes by. Well, just to repeat a little bit, those are the San Bernardino Mountains. We're in the Mojave Desert. We're looking at a big landslide here, and what's interesting to me is that this is the second landslide that occurred in this one single spot, from this one spot up here in the San Bernardino Mountains. And another one over here, you can see a little rough ground. And the last time I was out there, there's probably still a Winnebago stuck out over in here somewhere. People trying to get in and look at it. But these are large landslides, and they're referred to as stirstrums because we have to put terminology on items, and there's special kinds of landslides, very large run-out type landslides that have gone a long way from where they began. We're looking down now at a Google image here. Here's Highway 18 in here. Here's the landslide. Here's Highway 247. And if we track it on back over in here, you can see the top part of the landslide. You can see the top of the mountains in here and the path it took. This was studied originally, and the idea and the concept for it was that it must have jumped a ridge and separated the rock into a large debris mass that rode on a cushion of air 5 miles out into the desert. 5 miles is a long way for dirt to travel on dirt, no matter how high it starts. So the top of this is somewhere in the order of 9,000 feet. The desert rim out here is on the order of 4,000 feet, so there's about a 5,000 foot difference in elevation that it had in terms of the energy to get it there. But it's a spectacular feature. And the more people look, the more they're finding these. They found them up along the Sierras, the evidence of large landslides out there. And as you go up into Death Valley and further up in the mountains, you find these. The question to me that I'm interested in is, why did it happen here, and why did this first one happen here and the second one happen here out of the same area, and no other place along this entire mountain front do you find a landslide? Now, there's something going on here, and it has to do with geology. And this is just my little spin on engineers and geologists. Engineers like to build fences and put piles in the ground and stop things. Geologists like to understand what caused these things. And they are caused very specifically in certain places only by geologic factors that lead to them, and water, of course. So it's a combination of these things, and we think in this case it's probably reasonable to assume that there must have been some sort of earth-shaking or earthquake event to stimulate or cause this to happen, rather than to have it happen just in the course of events. And so actually right along here and moving along this Highway 18 is a fault called the Hellendale Fault. I don't know whether that would have caused it. Also behind the mountains back over in here is the San Andreas Fault. Any one of those could create shaking sufficient to loosen the mass. But the geology of the site itself must have caused that event to be specifically right in here. And fundamentally there are distinct rock types in there that, in my opinion, we're working on this, are the reason for that. So, well, let's look at the kinds of landslides that exist. And there's a whole nomenclature of them, but there really are three kinds. There are rockfalls, landslides themselves, and debris flows. Landslides are block movements of the earth. It stays together and slides down along a plane of separation between it and the surface from which it started. A rock fall is exactly what it says. It is something that has tumbled for some reason, usually rainfall of some kind, but it could be earth shaking, or it could be caused by human factors like building a road and not paying attention to the geologist's opinions about the security of the site. It could be a volcanic rupture. This happens to be a site in Honolulu, in Hawaii, where rock falls have been responsible for a number of deaths of people. They have built fences, but they continue to fall down. You can see the size of the rock here is about, I don't know, size of a small car, 7 feet in diameter here, weighing tons. And I don't know if any of you have ever, these are obviously happening on slopes and they're tumbling down and rolling along. And I don't know whether you've ever experienced that, seen something doing that. I have, basically on stupidity, but I was mapping in an area in a slope, and the guy was working with a bulldozer, and I just happened to wind up below him while he was making a road up there, and it was in granitic rock, so they were nice big boulders, and he got one loose. I just happened to look and see this thing start tumbling down towards me, and I wasn't sure. I got up on one of the boulders, and I wanted to go right, and I wanted to go left, and I wound up just standing there as this thing came and hit the boulder I was on and smashed, since it was pretty rotten, as a matter of fact. But just the impact of it knocked me over the side, so it's difficult to avoid them even when you're aware something's happened. And often people are in a position where they're sleeping in a house, and this thing is rumbling down the road, you don't hear it particularly, and it will hit, and it enters the house through the walls and can kill people. And this happened here locally. Out Santiago Canyon, there happens to be a unique set of conditions. I was involved in a law case on this briefly, and it was where a girl was killed on the second story of a home in Santiago Canyon based on a heavy rainstorm and a boulder coming loose, 2 boulders actually, coming down and winding up going through the house and killing her. And the concern was, how could this happen? When in fact it had happened just about a year before this, and a boulder had come down and hit the house and gone through it out to the road, and the people rebuilt and stayed in the house despite that. So you can get insurance against things like this, but you can't bring somebody back from something like that. To be aware of what the problems are. And actually the county had, in fact, produced a report from years back that indicated that spot was a dangerous spot. But once you have your home, you're very unlikely to give it up for what might happen. You're all aware of that. Homes are hard to come by, attachments grow, and you don't think it's going to happen to you. But sometimes it does. Over here, this is a debris flow. This is a different matter. This is a charged mass of water coming down a canyon, and it's got rocks, boulders, and mud in it, so it's a loose aggregate of material shooting down often, 30, 40 miles an hour, maybe faster than that. And so you can't outrun it. You can maybe hop a side of it. And it's a linear, it's coming down a canyon, it's picked up everything in the canyon bottom and is moving it along as a great mud-charged mass of material. I have some more photos of it to show. And so this is a very rapidly moving feature. It's devastating to the area it hits. This is up near DeVore, and this is in Waterman Canyon. It was a place where there was a retreat in there. And when you go look at it now, you can see where it took houses and just sheared them off, tore whole trees out, and people were killed in these instances as well. And we'll get into why that happens. And then over here, this happens to be a Laguna landslide here, the most recent Laguna landslide. And it is showing a breakaway here, a scarp we call it, head scarp region here, and the material has moved as a block down and away from where it was at that time. And I have some more detailed photos of that to talk about. So those are kind of the 3 different types of things that happen. We have names that go in between these, but they fundamentally fall into this. Another place that rock falls are pretty critical is Yosemite Valley. And some of our national parks have these problems, and they have begun to address this. Caltrans has begun to address these problems along the roadways of California and looking at where the problems are and what they need to do to fix them. They have begun to take a scientific approach to it, meaning they're using geologists to assess it and then following that with engineers to fix it. Okay? And I'll show you how we study them and how we fix them. But turns out big volcanoes and other places have landslides, and you can see a very big one right here that's come out of this area and other debris that look a lot like the Black Hawk landslide in there, a big chunk that pulled out in here, and this is an enormous feature on the surface of Mars. And there are people that study this. Obviously this isn't an impact or a problem for us, but it gives us information as to what is reasonable to expect or to attribute to the mechanisms for how landslides occur. Huh? I'm going to show you this, but a lot of people ask me why I got interested in landslides. And it kind of goes back to when I was at the University of California at San Diego. It's where I got my undergraduate degree, and had a had an outstanding career as a lawnmower and agricultural specialist of that nature until fortunately I was hired by the U.S. Geological Survey. I had my own office in the fisheries building overlooking the ocean at Scripps, and I still have to wonder why I left that and went on. There must have been a good reason. And but while I was there, the Fisheries Institute is on a big bluff of Eocene and Cretaceous rock formation. And I was working for a fellow there, George Moore. And one day he says, "Come on, John." This was typically how he used me. "Come on, John." Didn't tell me anything about it. And then we'd wind up somewhere, like on a boat or out doing geology. And he said, "Come on," and we walked outside. He says, "Here, hold this rod." And he had to transit. He just had me going around measuring. I said, "Well, what are we measuring here, George?" He says, "Oh, well, half of the fisheries building here is on a block of a landslide that's dropping down into the ocean over there." I said, "Oh my God, what side are we on?" We're not on the good side, John. As secretaries that come by, "Oh my God, this thing's failing." It's failing, minusculely. It was just really creeping. It was a true landslide block, but not a catastrophic failure, fortunately. At any rate, it got me very interested in how these things happen, how they impact what you can do about them. And as time went by, I wound up being more and more interested in them. I have some pictures of these things in motion. And if you don't mind, we'll take a few seconds here and see if this doesn't work. YouTube may have... I'm not sure it's going to work. No, I guess not. That's too bad. Oh well. I'll tell you what it is. It shows a picture of a road in Japan. It has power lines going along. It's a big slope like this, and it's all heavily forested. And as you're watching it, all of a sudden you'll notice that the whole back part of the picture is moving downhill. So the whole block takes off, the power lines snap like this, and you see trees and trees after trees coming down and falling down and going across. It also has a picture of debris flow in Devore, just like the picture I had there, only it's in motion. You see huge boulders sliding down the road and sheets of mud and gravel going on there. So I'm sorry it doesn't work. I thought if we had ourselves connected to the internet, it would function. It has always before, but anyway. Well, let's continue, and we'll have some other cool pictures here. This is the United States, and it's giving us an idea of where the potential for landslides for us might be. And the U.S. Geological Survey and the California Geological Survey are organizations very involved in this, producing a series of maps and that show where this problem is. This allows insurance companies to evaluate whether they want to insure for something. Landslide insurance is difficult, if not impossible, to get. But along here we have red areas, very high potential, yellow areas, high, and green areas, moderate. Landslides do not occur in the black areas. And you'll notice that even in the central part of the country, we have landslide problems, but they're primarily focused along areas in here where we have hills and topography along stream beds. And then, but for the most part, it's where there's mountains and where there's rainfall. You have elevation or topography, and you have rainfall that hits there. They're going to have the general term for all this, mass wasting, removing the land. So land comes up, the weathers, is attacked by rainfall and sunlight and heat. It changes the minerals, it weakens the rock, it erodes, it comes into streams, and as I said, those streams then carry all that debris to the ocean, where it settles out and undergoes another series of cycles in the geologic process of tectonics. So these are just the natural progression. They're not exceptional. It's not, wow, that's never happened before. This is what's gone on now and has gone on time immemorial, will continue. With one exception, as you look in here, the Sierras don't have a lot of landslides in there. Usually I stop and ask my students, why do you think that is? But I'll just tell you that the rock that's in here is exceptionally strong granitic rock. It was glaciated, so there's not much soil over the top of a lot of it, and you don't tend to get much in the way of large failures there. There also are not much in the way of significant earthquakes, though they have been in here. And so despite the fact you have high mountains and rainfall there, you don't tend to get many landslides in there. Although I've seen some pretty big ones up in the Calaveras County, where you could see a debris flow that had come down, taken the road out, eroded trees up to about twice my height, and come down and dammed up a river, which then overtopped it, flooded it, and sent a big debris flow downstream. So things do happen, but they're not particularly as common as in the other areas where we have soft sediments and a lot of rainfall that will cause us to have landslides. So over in here in Southern California, we've got the San Bernardino Mountains over here, San Gabriel's, and down in the San Joaquin Mountains, the little hills in these areas, and up into Santa Barbara, San Gabriel's, and the Coast Range Mountains up in this area. A little bit in San Diego down in here, mostly because of bluffs and a little bit of rainfall that is affecting very weak rock. So it's the geology and the presence of rainfall. Where there's very weak rock and you get a lot of rainfall, you'll tend to get things happening. So we classify movements. I mentioned that we have falls, slides, and debris flows. But there is a classification of it. You don't need to memorize this in particular. So landslides are these block flows like this. Rock falls in here will collect at the bottom, a term we call talus. It's steeper here, shallower here. Soil flow or solifluction is just the surface soil moving along. It's saturated. Mud flows are confined to channels and the outwash from channels. And slumps are basically landslides as well. So do we have any slumps around here in the San Joaquin Hills? Do we have any slumps around here in UC Irvine area? Not particularly here. And there are reasons, geological reasons for that, as opposed to in the San Joaquin Hills, in Laguna Beach, where you begin to get into a different geology. There are secondary evaluations of this, the nature of the slope material. These are the factors that influence it. And so loose sand or sandy silt, you may have heard the term the angle of repose. And the amount of water present can be dry or wet. Angle of repose is the natural angle at which it will remain in that slope. If it's steeper than that, it won't allow itself to be steeper than that. And the usual example is if you go on the beach and start building your little sand castle, you can only build it to a certain steepness, about 33 degrees on sand. Naturally, different types of material, gravels have different angles of repose. Unconsolidated mixture of sand, silt, and soil. The steepness of the slope, moderate, whether it's dry or wet, prone to slump, may be stable. So we have classified things as to the ability. This allows you to approach the landscape and define it in terms of whether it's likely to have a landslide or not. And these maps exist, although I haven't put them up here, as they're probably, don't mean to diminish your intelligence, but they're very difficult to interpret. And a good example is the Santiago Canyon, examples of the potential for rock falls. Just because there's a potential for a rock fall, what does that mean? It means there might be a rock fall in there, might be a debris flow in there, but under what conditions? Where exactly is that? Do I need to move my house? Do I need to leave my house? Is the fact that I'm seeing that going to make me want to leave my house? Probably not. So you need a geologist actually to interpret his own kind of manuscripts and mapping that shows you where these problems exist. We had our own vice president called me up and said, I'm buying a piece of property and I'm worried about landslides. Can you recommend somebody to come talk to him? Just come look at it for me. And I thought for a minute he actually meant me, but I decided I think it would be better if you had somebody, and there are a number of people, some sitting in the back, who will do this for you, and you can call and get that information and get a clear read on what is or is not a problem at your house. If you live on a slope, you may or may not have a problem. Well, there's a nomenclature for these, and you have the crown is the top part of the landslide area which has not moved. It may have cracks in it. Like if you have a house up here and you see a little bunch of cracks along the edge, this is not a good thing. It's not good. You should call somebody. You see those cracks, you want to call somebody. There's a head scarp here, which is the actual surface of the slip plane along which the moved mass of material is flowing. And the slide plane itself is a very narrow, well-defined zone that can be a little thicker than not, but it's a fairly well-defined zone, maybe like that. Well, there's a big block of material, maybe the size of this building, a little thin zone like that. That's along which this movement is shearing, and then below that it's stable. This whole thing will move, be fairly undeformed unless it's a slump, in which case it will begin to break up on both ends as it moves. And it will tend to move fairly slowly in this case because it's shearing along a clayey material in here as a break between two rock surfaces. So it's not going to move like a column of water. And you can typically move around and get out of the way of these things. Then the toe is the lower surface that has shown movement or along which debris is collected over the landscape that's stable. And we have a lower flow in here and the upper slump up in there. There'll be cracks that are developing in this, and there are radial cracks down here, horizontal cracks in here as it moves over the landscape and down. Well, how do we identify or evaluate these? And very simply, there are a number of ways to do it depending on the actual geometry of the landslide. But geologists, in order to identify whether an area is stable or not, will take into account the various properties that are represented here in order to look at the forces that would resist movement divided by the driving forces and get what's called a factor of safety. The factor of safety means that if you are over a 1.0 or at 1.0, then these resisting forces and driving forces are balanced. They should be stable. Right? If it's lower, then it's moving. That means that the driving forces are greater than the resisting forces. Your factor of safety is 0.9. This is not good. This is moving. If not moving now, it's moving soon. And if it's greater than that, then it's stable. If it's a lot greater than that, it's pretty stable. If it's a whole lot greater than that, it's real stable. So there's a number in here that we all tend to use. Most cities will use. It's a factor of safety of 1.5. They will want your property to have a factor of safety greater than 1.5 before they allow you to build, or you need to demonstrate that if you're in hilly country. And geologists, particularly engineering geologists, were involved in the development of large hillside developments, must evaluate the geology. They will take samples from the various rock units, and they will undergo these analyses using these various factors, the weight of it, the shear strength, the length of the shear plane expected. And so there's an analysis to all these slopes that are going to be there, that are there now, or that are going to be there in the future, because they're going to steepen them up. The steeper the slope is, the more houses you can rack in there, right? You take the toe of the slope back, put some more homes in there, put another street on there. And so they're doing this evaluation, doing this calculation. Now, this is the way we did it when I was in my 50s. When was that? A while back. Well, and it used to be that we would run these things very much by hand, and so there would be a limited effort, because as you can see, there's a lot of numbers being generated out of this. There's a lot of work being done in a lab to get values to put in there. Nowadays, it's done by computer, obviously, computer programs, and there are zillions of iterations of this run to get the absolute lowest factor of safety expected, and if that's above 1.5, then everything's cool. If it's below that, then we got to start negotiating. Okay. One of the cases that I worked on as an expert witness was with Mr. Monks versus the city of Rancho Palos Verdes, and which we lost and won, I think. I'm never really sure about court cases, what you win when you win, so may still be negotiating on this. But, and I will show you towards the end, I'll sort of wrap up with this as well, but it is an area of an ancient landslide complex where to get a factor of safety of 1.5 was a real trick. But a lot of work had been done. Places are moving today. Places have been stabilized. Very complex. And going through all this in front of the judge and explaining all of the things that I've been explaining to you was troubling, especially when he appeared to be asleep. But occasionally he'd wake up and ask a question, so it encouraged me. Well, at any rate, let's not try that again. We went to court because people owned empty lots mixed up in a number of people who already had homes. Some of the homes had burned down and they'd replaced them. Some of the homes had new additions put on them. But the weight of one additional home built on bare land was going to cause this landslide to go. And that's what the whole fight was about. The city was, in fact, doing a taking of private property without compensating the owners. And so the idea was, where is this area? How likely is it to be undergoing a landslide in that area, to activate the landslide and cause these people to have problems? We were using global positioning satellite surveying, which was done wrong. We were using other surveying techniques, and we were using standard techniques to assess slides. You can see a landslide that has happened here to a home. This home is abandoned. This wall is separated off. It's cracked down here, it's sheared in here, and this whole mass. This is the edge of the landslide going right through this house in this area out here. And the way that we investigate them, we need to get that information. Where is the slide plane? What kind of material is composing the slide mass above and below? And where is the water table? And we need that information. You can only get that fundamentally by jumping down a borehole and putting your nose against the rocks. This is the fun stuff for geologists, okay? You don't get to see this stuff if you're just sitting in the classroom normally. So when we're out in the field, this is called a bucket auger because it's got a bucket here tied up in a drill rig here. It sits down this annular ring and it reams out a hole in here. We have the driller and the swamper over here dumping the dirt out over in there, which hopefully will not go in the hole. Generally would like to have a little more space in there. But we're up in San Diego here. We're looking at that landslide. Here's the borehole, nice clean cut. We've got a tape going down in there so you know just how far down you are. And occasionally it fills with water. It's disturbing if you're not getting the attention of the driller, who sits here and has the rig fundamentally off but lowering you down on a nice secure cage here. It's got a light up here. He's got a hard hat in case these big rocks fall down and wonk you in the head in there while you're working. You'll have your brunt and your compass to measure the inclination of the rocks themselves, a pick to open it up and see what it is. And while you've done all this, you will have taken some samples as you're going down. But it's looking at it and seeing exactly where that slide plane is that's critical to making the model work that I just showed you. And when you have that, when you understand why it failed, then you can understand how to engineer it back to a stable position, usually by removing it and replacing it. Fundamentally. So this guy is a geologist. He's going down to take a look at things. When I did it, we just had a piece, 2x6 board and a couple of ropes up there, but that was deemed a little more dangerous than it should be, and you have to be careful, obviously, doing this sort of business. He's headed down. Here he goes on down. They've cleared this a little bit out in here, and he'll be investigating using a light and seeing what the geology looks like. Well, those investigations are typical not just for a landslide, but in preparation of understanding all the areas where people are going to build homes in hillside areas, because you have to get that information from down in the borehole. You have to tell whether it is or is not a landslide. And actually, that's how I got my job coming out here. From a company I was working with before I went to the university, was the geologist that they had absolutely refused to go down a borehole. And I said, well, I'll go down that. I don't have a problem with that. So they brought me out, got my job, and it was all downhill from there. Right. Well, forest falls. In my wife's birthday in 1999, Forest Falls is an area out near Yucaipa, out in Mill Creek, and it is in the San Bernardino Mountains, but it's also right near the San Andreas Fault. This area has been uplifted very rapidly and formed into mountains. It has pine trees, but you can also see it has this extremely steep slope as this river, Mill Creek, has cut through it down in here. It's very big debris, and these are the traces of the debris flows that will come, and as they get down in this area, they will spread out. Places like Wrightwood have these problems too. Debris flows or mud flows that will come down into and through the trees in there. And you can see two things. One here is a new debris flow that came in and through there, and we're looking at here. And there are also evidence of old debris flows in here. So as geologists learn to look for these things, they can see them and they can identify that this is indeed a fairly problematic place. And as you look at the scale here, you can see that the debris flow came down on this pine tree and tore the bark off this thing to that height. So they come through as a rapidly moving mass of rocks and churning mud and debris that's water charged, and they will go around these things, or actually at times they'll just tear them right out of the ground. And you can see the house over here has suffered greatly for it, and people suffer greatly for this. So this is a debris flow, and debris flows happen when it rains. It's going to be raining for these to occur because they are a function of the landscape being saturated and flow being concentrated into either the canyon areas such as this, or just in fact saturating the hillside, and sometimes whole portions of the hillside will cut loose and become a debris flow and slide down there. But they're generally channelized features, and they will come down in here into that area. So this is Forest Falls was hit and hard hit by that thunderstorm, which happened in July. So you wouldn't figure that in California. It's an odd thing. It happened in July. So you wouldn't figure that in California. It's an odd thing. Conchita. Conchita is somewhere between a slump and a mud flow. And here's the scarp. This is the head scarp of it. Here's the crown of it up in here. Here's the main head scarp. As this piece here broke away, there's smaller scarps in there. So it's a block of material that came down and ran into the homes here. And this happened in '95, and you can see the water bleeding out of the bottom of it here and draining out. And the people have their homes sandbagged to prevent that from hurting them. Well, the response to this was, we'll build a wall. So we'll keep that from happening again. So they're called soldier piles, but they put in steel I-beams, like so wide, and pound those into the ground, and then put railroad ties in between them so that they form a barrier against any further movement in there. And that was done in order to allow people to remain where they were. It was an engineered solution based on what was seen here, and figured that would take care of it should, in the totally unlikely event, this ever happen again. Well, actually it did happen again, not soon after. Here's a aerial view, the original. There's a scarp in there, and a secondary mud flow or landslide happened in this area in 2005. So here's a picture of 2002 of this area. Here's La Conchita. You can see it's nestled up against, you can see the little scarp of the toe right in there. And that scarp is very linear in there now because they have the wall. There's that wall in there protecting it. And you can see the head scarp in here. You can also see over in here, this has slumped in the past there. There's another scarp. Here is the crown of the landslide in this area, and a road that once went up along in there. And it turns out that geologically, this area is composed of a couple rock units and some faults that run up this way, and the rock units are inclined as well and climb up this way and get to a point where they become a problem, obviously. So the stability geologically is a geologic feature, and you get little debris flows and smaller features out here. So these people probably are far more secure than what's happening here, just based on what did happen. And again, there's the 95 block failure turned into debris flow, fairly dry. You could see dust rising out of this despite the fact there's water running down the street in there. And then a secondary slide happened. Here's the details from the people at the U.S. Geological Survey actually did this. And here's an image of it. Here's the old one in here. Here's the wall along there. And here's the new slide that came in. And you can see it was far more devastating. In fact, several people were killed here. And just the luck of the draw as to who that happened. But it happened virtually in the same area here. And not soon after in 2005. And you can see there's looking from the top elevation of it, this landslide mass. And this is really high up there. I mean, it's like 50 feet up to get onto the mass of this landslide, if not more than that. Here's a house over here. These houses for scale. It just annihilated this portion of the area and then overflowed and over in here. And you can see the little ribs here of flow as it flowed out and onto the landscape in there. This is an example of soldier piles here. Here's the beams put in, and then they're going to put there. This is another place. This is actually in Laguna Beach in here, but this is what's typically done to try and stabilize. These are driven down quite a ways, and then you'll have boards put in and try and stabilize so that this won't continue to collapse anymore up in there. So let's go back for a minute. Let's go back and look at this. As you can see up here, this is an orchard, right? And as we look back further, more evidence of this orchard back in here. It's a big ranch back in there, and the people down below basically decided that they're responsible for it. It was their fault because they put water into this unstable area and this caused somebody to die. And it turns out that this orchard, in point of fact, is on drip, and that this drip has been adjusted scientifically to make sure that the water does not get deep down into that ground. But even so, they lost. And the ranch lost. The ranch basically walked away. It's yours. And we can't do anything. It's your problem now. So notice also down here, this is the older. So let's go forward again. The wall that was in here. The reports indicate people were saying they had TV cameras because they were concerned about this. There being possibly there'd been a little bit of failure in 2005 before the main thing broke. And they had a TV truck parked up there, and somebody, I guess the story is, walked up and said, you better move that. This thing we can hear it moving at night. We can hear this thing starting to move. And they moved that, and as they did, this came down, took the wall, and basically just pushed it over. Just take all those steel piles and just bent them snapped them off like toothpicks, and the dirt moved out there. So we're dealing with a fairly significant and powerful force here that's working against what we want to have there. So these guys here are mostly a interim measure, and we'll look at Laguna Beach here in a second and talk about what those interim measures mean and how much you can really get away with and how little you can get away with. But first, let's take another trip around Orange County. Here's Dana Point up here, and San Onofre Mountain in here, and the road to San Diego is out in here. And this is more, I want to show you how landslides happen and the timing of them with this. So San Onofre, the Marine base decided this land was just absolutely too crummy for them, so they gave it to the state parks. And there are various reasons why they did that, but fundamentally they kept the good stuff down here and gave the bad stuff to the state parks in there and kept the stuff up here too. But there are a number of landslides in San Clemente that happen up in a particular rock unit, and there's a particular rock unit down here within which a number of landslides occur. And this is pretty fundamentally true. There are certain rock units that are more prone to having landslides happen in them than others. One's the Topanga, the one's the Monterey, and one's the Capistrano Formation. The Capistrano Formation occurs back in here, back in here, and up this big valley in here. So all of Mission Viejo and Aliso Viejo and back area of San Clemente are all built on this Capistrano Formation. Capistrano Formation's under us, certain areas around here. But then also the Monterey is composed here. Monterey's also up these canyons here, back over in here, and up into Mission Viejo as well, and it's particularly prone to that. These are shale rock units. They're muddy units, deep sea muds that have been compressed, dried, and are now above the ocean, but they are problems. Then the Topanga is in Laguna Beach. The Topanga Formation is actually a sandy and gravelly formation, but it has shale in it. And that shale is the real source of the problem in it. And I'll explain that as I get into it here. So here we're looking down at San Onofre, a little closer here. Here's the freeway and the railroad coming down here. We're looking over in there. And these are outlining the number of landslides. You can see the scarps of them, the head scarps back in here, all along here, the entire distance of San Onofre State Park. When you go down there and you go down to the beach, you're walking over landslides for the most part. And these are separated often by these big canyons that come down. You can see this canyon excavated in there, canyons coming down here. And if you take a closer look at them, you can see them develop and change over time. So here I'm looking at the very northern end of San Onofre State Park. The San Onofre Nuclear Generating Station is off to the left in here, and these are the same area over different periods of time. Here's 1972. You can see it's completely in preparation for it to be an area where they were going to have camping. In fact, you can still see the camping rings and fire rings and stuff and barbecues in there. We had a road coming down, and here you can see it's a little more developed in there. Slight changes in here, and here we come to 2002. And you can see that there are pieces starting to break off here in chunks. And then again, this chunk is now separated. And why? Because the debris is falling off this headscarp. And you can see it's a real reddish-brown unit as opposed to the white over in here. And this white is the Monterey Formation, exposed well out here, which is a really very weak rock unit. And this is a terrace deposit or alluvium that's come out of these channels thousands of years ago and has covered it up. You can see right here how distinct the change is from landslides to non-landslides. This is a sandstone formation, forms nice vertical cliffs with absolutely no failure problems on it. A rock drops out of it now and again, but generally no failure problems. Whereas over here, it's eroded almost back to the road. As it continues to erode, it's forming these little horseshoes in there. And there's a fault right here that places this rock unit against this rock unit and brings this one up and exposes it right along the beach line here. And so you've got failures happening in here. And this whole point in here is moving slowly over time. The cracks will open back in here. It'll expose the back in here. This will collapse onto it and continue to drive it, just as if you were pushing it slowly like this, and then it will collapse out onto the beach. The beach will rise up and wash it away, take away what's resisting movement, and then it'll move out again. So it's a systematic process of erosion that's going to ultimately take the freeway. And so far as I know, the San Onofre Park has said, we know that, we're just not sure what we are going to do about it, if anything. So obviously these are dangerous places, so I like to take my students there. And show them dangerous places. You walk up in here. This is so overgrown now, it's very difficult to get in, but at one time you could walk right up to the base of the cliff, and you can get out, and they'll allow you to walk right up to the edge of this and look over, but you can see it. These failures are happening all the time in here. This is actually showing you where one began there that didn't exist before. There was this little slump on here on the beach, but as you look here, you can't really make out any cracks or breaks in here. You can't see this big canyon in here coming down here, this eroded canyon. And then all of a sudden these linear scarps are exposed as this whole block has moved out this way and into this canyon. And then this is slightly eroded, and then this whole face has slumped and down and onto the beach, and now it continues. You can actually see the clay right in here that is the soul of the weak clay of the Monterey Formation that rolls onto the beach and takes all this red stuff and just throws it onto the beach over time. You get big storms. I had a student down here looked at it over a period of time as storms coming in and how much material's moved, and you can see that it's now sinking down and moving out here bit by bit. What impressed me about this, and the reason that I have been interested up until 911, when they became concerned that guys like me were after the San Onofre nuclear generating station and refused to let us go in there with ladders or anything that might be suspicious. Science is suspicious to a lot of people, creates suspicion. And but at any rate, so I put that on hiatus until the Al-Qaeda is defeated and we can go back to here. Hopefully I'll still be kicking around. You can see we're out on here in this the slope, but you see that this is still, there's a lot of stuff in there. There's a big block, even though it's sunk down here. It's sunk down along its slide plane. There's a single plane that's exposed there along which all this is sliding. And then it will collapse behind it in here, and it will ultimately create it. But this block here, whoops, there's no block here. There is none of that stuff. None of the red stuff there. It's all gone. The whole thing has slid out of here at some time and disappeared, and it has slowly collapsed back onto the surface and continues to slide. So it's so weak it really doesn't take much to move material out along this thing. But at one time people said, well, that's the head of the landslide. That is that's this portion of this landslide, but in fact it's not, because all the red stuff's gone. So that can't be. This whole portion that's back in here has been eroded at some point in time down there. So a much older feature, in my opinion. Proving that is another matter. But that ultimately will happen here, and you'll have another big arc, and all this material will be gone and will begin to eat its way back. The reason this is happening is right here, this big canyon. And I don't think I put my photos in here, but you can find, if you walk back in these canyons and look at things, you'll find cracks in the ground and as the whole area is moving along. But what is up there is when they built the highway there back in the 40s, 30s, back in the 30s, they built the highway there. They put culverts underneath it to take these big streams here during rainstorms and bypass, so it wouldn't come over the road, bypass it, and just dumped it into this drainage here. And those culverts, when you see them, are now exposed over 7 or 8 feet high from the base of the new floor of that canyon. They didn't build them that way. They built them so they would just flow out onto where the bottom of the canyon was at that time. And what's happened is it's eroded itself back and is continuing to erode back and underneath that. And so what it did is expose the slide plane down here, expose the top of the formation, the Monterey Formation, and when it did that, at a certain point, it created enough instability that the whole thing began to move, and it was like that. As you can see, I mean, here's 70, 72, 79 here. 78, 79 actually was a big rain year, so we had a big erosion in here, and this whole thing now beginning to move. And so the human intervention we have to add into the equation along with geology and rainfall and perhaps earthquakes, but earthquakes aren't an issue here particularly. So these are developing, they're creating, and in this case, while it appears there's been no human intervention, in fact, the cause of it, in my opinion, is that they put these culverts in and allowed it to erode down to a problem place where it became a problem. And that's why it starts right there. It doesn't start back here, doesn't start out here. It started right there because that's right where you exposed the contact between the red unit and the white unit, and it created it was no longer buttressed or held in by the alluvium that was in the channel. So it took all that away and went right into the canyon. And these are the sorts of things that happen. That's why these landslides happen, is due to conditions that may be long-term but short-acting. Well, I did have it. So here we are. Here's where their lip of their culvert is as they brought it in, and things have eroded themselves all the way back here. There's some cracks that have opened in the canyon here, and you can see this block has moved and there are cracks coming up here. This is the boundary between the moving or slide mass and this area. So when you're ground truthing it, I mean you're looking to prove and find evidence for what is happening. And then here, you can see how weak this Monterey Formation is here. Here the whole thing has been picked up and folded, and this material is moving over on it. And here is the landslide plane, the surface on which this material is moving, and it's probably been peeled off a little bit, kicked up, and there's a series of these being presented to the ocean, and this is no longer there because couple winters and it disappears and new stuff comes in that continue to erode away. And here you can see it moving out onto the cobble beach, and this pattern in here, then it gets repeated as it erodes this material. These will fall off in there. So by the way, a word of warning on this in most places is these are not good places to go sun yourself up against here. So you have a backrest there. Those are not safe areas. They lose people. They don't write this up much in the paper, but people get killed along the bluffs, particularly here and down in San Diego. That can happen very quickly. It doesn't take much dirt to fall on you to snuff you. And again, you can see San Onofre here. You can see the nice line of bluffs and the fault here. Now you can argue that San Onofre picked a nice spot because this is all very stable coastline. On the other hand, it is the fault in there, right? However, we have evidence that that fault is not active. So, no worries. Really. Anyway. Laguna Beach. This is the Topanga Formation in here in Laguna Beach, which underlies a great amount of the hillside area in Laguna Beach. I actually lived in Laguna Beach for a number of years till it became untenable. And my house looked directly over at this place. And they're actually to the left here is the 1978 Laguna Beach landslide, and it was repaired and put into good shape. And when this first happened, I think a lot of us thought, oh my, that whole thing wasn't done right. But in point of fact, it was done right, and that wasn't the area that failed. It was the area next to it that failed. So here's the area that was fixed, the Laguna Beach landslide, Bluebird landslide it was called at that time. All this land was put back in, and these homes were rebuilt then. These homes were left alone, and this is the area that failed, this long linear area. And so geologically it was for a different reason, but it's quite close to it. And I'm sure most of you read about it. I actually got interviewed on TV for this, and it was a lot of fun for me, not fun for these people. And here you can see the edge of the landslide coming in here, and you can see this driveway, which comes up to this all busted up concrete house in there. You can see the headscarp back in there, and the edge of it coming out along here. So this long, rather odd-shaped landslide here. And there's a creek down in here, in Bluebird Canyon here. And this pushed all this material up and dammed up the creek in there. You can see the side scarps in here. This actually used to be right there. That's where that driveway was. So you can see that it moved it a good distance here and then avoided these people in here. And this was all hummocky, torn up terrain in there. Just another look at it over in here, and again at this area where this side scarp was and the head scarp. You can see this house barely hanging on here. This guy's fallen down. This guy rode it out. These won't be livable. In fact, they had to all be taken out. Close-up of that structure. And the area where it happened, you can see that there were landslides in this area before. TT is geologies for a tertiary geologic age, meaning it's about 20 million years old, and T for the Topanga Formation, meaning it's a rock unit that is very similar in its character over a great distance. And these others are Monterey Formation in here, TM in there, etc. TSOB is San Onofre breccia, generally good stuff. At any rate, this is the rock unit that it's in, and so there were a number of slides. It's well known. These people that were in here built their homes, though, back in the 50s and 60s. And when you look at the reporting that was done on it, it was fundamentally, is there anything wrong with it now? No, let's build a house. Anything wrong with it now? Nah, looks good. We don't do it that way now. We go in and investigate it, and we propose what might happen. We look at underlying features. And the reason is that in the 50s, there weren't a whole lot of geologists around doing this. So it was mostly engineers. I really sound like I'm bashing engineers, but I'm not. Just the state of the knowledge, the state of the art at the time was quite different. And so these people didn't have that advantage of having a specialist or a geologist. In fact, it really was only later in the 60s that an individual in Southern California, this whole process of understanding how these mechanisms work, how these landslides move, really began to be recognized as a problem as development went on. After World War II, of course, everybody decided that instead of going back to Wisconsin, we'll just stay in San Diego or LA. Sun's out here more. You don't have to shovel snow unless you want to go to the mountains. And so the population swelled here, and land and the people moved into the mountains. As they moved into the mountains, they impacted them, did things that ultimately resulted in instability in those mountains. Whoops. This is a close-up picture. Here's a pencil stuck in it. And you can see that there are sands in here and gravelly pieces and fine grained materials in between it here. So it's actually allows water to flow in through the sands and build up in the shales and the clays, and makes them weaker, and you tend to really get landslide problems in material like this. And Topanga is one of those formations in which that happens. And here's the map and the drill holes of the area where the geologist doing this, which was Geofirm, the Laguna Beach company, but they're also associated with some friends of mine, and there's their boreholes, logs, etc. And they had to go in and do this investigation first in order to determine the stability of it as it stood there, and what they had to do to stabilize things before they could even determine what they were going to do to fix it. So the first thing that happened is there's an emergency, and geologists were called out, and they began to investigate. And they told people, you guys can stay. You guys got to go. This headscarp's in danger. One by one, they would let them move back into certain homes, depending on whether they felt they were secure or not, whether they had secured the area. We use a tool called an inclinometer. What it is a little device that's on racks, and in a borehole we'll put a pipe that has notches in it. We'll run this thing down, and as the landslide moves, it'll bend the pipe, and this thing will record the deflection. This deflection obviously is showing that something's happening. So here's a series of times in here. These are 14, 15, 16, 17 daily accountings, and you can see it's moving on a daily basis through here. So it did not stop. Thing went down, had a significant failure, and then it continued to creep along. And this causes great difficulty when you're trying to fix something. How do you stop something like that? And so these are the areas that they were able to had concerns about. The failure up in here of 6/12. This all happened on June 1st. And there's a small failure in here, the big failure, larger failure block over in there. So it's pieces of it moving separate from one another, and this is typical as well. And then this is showing you that the red is where it went down and by how many feet. The blue is where it went up and by how many feet. So the whole thing was down like this and pooched up at the bottom. And this is covering an awful lot of ground, and our concrete house is somewhere in here. So just to look in and see what was happening up here, there's a scarp up there, and the house is exposed underneath, and some beams that are bent and fractured out. And this house, in some places, guys were able to drive their car out of the garage and get out of there. Other places, people lost everything. They're taken out, and they're not allowed to go back in for safety reasons. So these landslides become political very quickly, and they become legal very quickly. And the homeowners in this area were quick to be concerned that the city of Laguna Beach had responsibility for this. The city of Laguna Beach said this is a catastrophe. We need FEMA in here, Federal Emergency Management people. And FEMA said, no, I don't think so. I don't think so. That's not big enough. But they actually did kick in money. But the money that came in to repair this, there's some images of it. Lateral shear tore through this house. You can see the homes and sliding down. Devastating. And then here they are fixing it. And it turned out that FEMA did bring in money and said we need to have it fixed, but the condition is we will fix it and return the land to the place that it was. and the lots that were there will remain those of the people who owned them, but we're not building the homes. The people had to build the homes. And like I said, a lot of these people had owned their homes since the 50s, or there had been some transfer. Obviously, people sell and new people come in. But pretty much they had their homes all paid for. Not. I don't think so. Everybody borrowed against it, just like we all do, in equity and other things and refinancing. And so you have to think, what would you do? You know, if you're given this little piece, so that's where Dr. Foster's home once was. You can go ahead and build another home there for $400,000 or so and move back in. And that's what those people were faced with. So they either had to sell or not. And a lot of people, had bought this as retirement homes or whatever. It was a very unfortunate situation. But the city of Laguna really reacted, I think, maturely. They obviously have experiences with this in the past. And at any rate, back to what they did. Here we are, and a bunch of equipment out here. You see a number of pipes in here. One of the things that you have to do to stop a landslide is to de-water it, called de-water, to get the water away from the base of the landslide so that it will no longer have that ability to move on its own. And to do that, you need to pump water out, you need to drill wells, pump water out, and lower what's called the water table down below the slide plane itself. And efforts were made at that, but it still did not stop the landslide. All the time they were down here digging this material out of the canyon in order to put a pipeline down in the canyon and stabilize the base so they could begin to build back up. This landslide was moving in on them. So they were working down there, putting up, working on little sections of it at a time, putting in their pipe, move over here, fill this back up, and protect that and stop it. And even so, they still, the geologist said he would get calls at 1 a.m. We're seeing this thing's moving faster than we thought. Said, oh, you need to get down here. And it's a very worrisome thing because of the potential to these people up in here who are counting on this thing getting stabilized. Well, here's all the work going on. They've got all this covered up with plastic to make sure when it rains, because they're working on this into the fall, trying to beat the rainy season in here and having some margin of success. And so here's the wall up at the head. This is the beams in here and the boards across in here to try and temporarily stabilize. They actually would leave this in eventually. But this formed a boundary so that they could stabilize the back here and protect these homes and keep them from falling in. Here it is, built up. I feel better, don't you? And here we are down at the bottom. They're down here. They're trying to control water with a pipeline in here. This, you can see, is bent a little bit. This thing is still moving in on the sides there, and they're trying to get the pipe in so they can backfill it and stabilize it and buttress it up. Here we are down the bottom. You can see they're concreting in down here. We've got these huge bolts in on here against these boards to try and keep the mass back, the old pipe in here, and they're moving along to put this buttress and then put a pipe on top of it. A buttress is a retaining slot. That will prevent the mass from moving. And here we are up at the here. Where are we exactly? Down here at the bottom after this has gotten filled up in here, and you can see the top of the retaining structure in there as they're working away. And as they got done, then what people would receive was a system of roads and bare lots. And in point of fact, your property, if you got your property back, you'd probably have about 20 feet here till it went over the side. And then so you would have to launch your house out, which is a very expensive proposition if you've ever done that, to put caissons in and support your house on piers, that sort of thing. Okay, Topanga Formation, Laguna Beach, and that is coming back to normal in Laguna Beach. If we go back here, though. However, there are these people over here, which is the next group beyond here. This piece over here went in 78. This piece went in 06. And it appears to be, in my mind, working its way up there. Oh. And lastly, my case in Rancho Palos Verdes. This area here is an enormous landslide in here. And this is where the people were. You might remember the Abalone Cove landslide that happened in 78 has been fixed in here. A lot of people over here, however, still live in land that is constantly moving. And what they do is put beams under their house, like those beams I showed you. And as the house moves and tilts, then they'll come in and jack that baby up, stabilize it, wait for the next movement, jack it up. Whole houses have moved from one side of the road to the other in Rancho Palos Verdes. It's almost like they're on plastic moving down here. Those same areas are still not sewered. They're still putting the water into the ground through their sewers. They still have lakes back in there. They still don't control runoff. They don't have any wells operating to dewater it. Whereas Abalone Cove over in here has no movement now anymore, has a series of wells, and they have what's called the Abalone Cove Landslide Abatement District, which monitors all this. A friend of mine at USC lives here and sort of heads that group up. And what they've done is that area is sewered all up in here, and that area has wells pumping water out, thousands, tens of thousands of gallons a day out of there constantly, and keeps it stable. And so very different approaches. This is the whatever group. This is the let's take care of business group over in there. And here you see one of the houses, and you actually can't quite see it, but they got beams under here. You can see that the water and gas lines have these little flanges in them so they can slide like this up to a certain point, then they got to fix them again. The roads are constantly getting torn apart in here. You can see the gully and the tearing apart of the land in here. So, I mean, I can't. But it's a really nice place. I'll say that. I liked it a lot. Pardon me?
Where's Trump?
Donald
Trump.
Oh, yeah, Trump is that away. Down over there. Trump Resort, yes. They have their own problems. A lot of areas. And it's all the same basic ancient landslide complex, which is initially moved some couple 100,000 years ago. There's a very ancient system here, very deep-seated, 160 feet down to the slide plane. And there are various geologic controls here and there on it that are interesting from a geologic standpoint. But fundamentally, they could probably fix it if they went in the sewer, but sewering costs money. Putting beams under your house and jacking it up, I guess, is the cheaper approach. And so, thanks a lot.